Hey everybody, this is like what page whatever it is. It's part three. So we're talking about triangle similarity. We're going to start with some basics. This is something that hopefully like you recognize from class. You've seen and heard these terminologies over and over and over again. But think about like why we keep saying it repetitiously throughout the course of the day, and why we keep bringing up the general definition. Like think about that. Kind of trying to tell you something about your test. All right. So the directions here are just like answer these questions about basics of similarity. So let's just do it. First part is fill in the blank. And so this is kind of like your choral reading, so to speak. So let's just put in the blanks here. So if two triangles are considered to be mathematically similar, fill in the blanks below that describe what must be true of those triangles. In other words, what's the definition? Well, here we have something about angles, right? But like it's not just any pairs of angles. We know that's going to be the corresponding angles. And those angles, by definition, for similar triangles have to be congruent. Remember, there's an inherent relationship between similarity and congruency. This is their link, that the angles in either case have to be congruent. If we're talking about sides, we're still talking about corresponding sides. But in this case, they're going to be what we call proportional. And here's how similarity is different than triangle congruence. Proportional means that all corresponding sides have the same ratio or scale factor. No surprise, because we've literally said that every day in class since like forever, right? Or at least 5 ever. So let's put that into play. So if I have these two triangles, A, B, C, and D, E, F, being similar, that means we can produce sets of sides and angles that have to be congruent. Well, first of all, marked, here we have B and E. And so corresponding angles have to be congruent, right? So that tells me angle B must be congruent to angle E. Okay. According to our similarity statement, A and D are corresponding, therefore they must be congruent. So angle A is congruent to angle D. And finally, the third angles, C and F. Angle C has to be congruent to angle F. Okay? Now, the other thing that has to be true is that corresponding sides are proportional. All right, corresponding sides proportional. Okay, so what that means for us is that we're going to take pairs of sides, say like AB, for example, corresponds to DE. And so if I take the value of AB, whatever length that is, and divide it by DE, that forms our ratio, and that has to be the same as the other corresponding sides divided together. That's how we keep producing like these decimal or times 2 or times 0.5 or 1/3 values. So if I take BC, and notice that the AB over DE has an order. It's going to be small triangle over big triangle. And so that has to be the same as BC over EF. Okay? Or if I take like these last sides, AC over DF. Okay? And again, we could have flipped those, but I have to flip all three of them to keep them equal because we're going small triangle over big triangle for this example. And so they all have to be small triangle over big triangle. And again, this is where how we show proportionality. We take those side ratios, we divide them, we make them, and show that they're going to have the same value. All right, so we can put that into action below. The proportionality is the same thing as finding the scale factor. Okay, so what I mean is this. If I take AC and I take A prime C prime, so if I take A prime C prime and take it over AC, those actually have numbers, right? And so that's going to be 25 for AC. I'm getting that right here. And then it's going to be 5 for AC. I'm sorry, 25 for A prime, C prime, and then 5 for AC. That's going to give me a scale factor of 5. Okay? And that should be the same all the way around, right? So if I take the same two corresponding sides, in this case A prime, B prime, because I established a large triangle, the prime triangle's on top, and so the small triangle AB, that's the same as 60 divided by 12, and you can grab your calculator. 60 divided by 12 also gives you a 5. Okay. Might as well check all three. So we have BC, both prime, over BC. That gives us 65 over 13. Okay, so if I take 65 divided by 13, I also get a value of 5. And so what's significant here is we can note the triangle is proportional because all the ratios are the same, at least the decimalized solved version, which means the fractions were, which means the originals were. Okay. Also, I know the scale factor in this case is going to be 5. Now we should pause a moment because we really have two versions of the scale factor. We have 25 over 5, or we have 5 over 25. Now we know 25 divided by 5 is 5. 5 divided by 25 should be 0.2 or 0.2. They're both valid scale factors because they both come from a ratio. But we should take a moment to appreciate that we're going from ABC to A prime, B prime, C prime. We're going from the small triangle to the big triangle. And so we're going to throw out this scale factor and we're just going to keep the 5. Okay. On the second triangle, we should check pretty much the same way, right? So we have SU and we have SU prime. Okay. Now, if I go SU over S prime, U prime, I'm just shaking it up. I did the other way on the previous triangle. I do end up with 12 over 8, right? So 12 divided by 8. Which I can reduce that down, use my hand-to-hand calculator, which I'm sure I have here somewhere. Oh, there it is. Okay, if I take 12 divided by 8, I get 1.5. Okay, so to check to see if these triangles are proportional, the scale factor has to hold for all three. And so I have ST over S prime T prime. That gives me 15 over 10. Well, 15 over 10 is definitely 1.5, so that's good. 2 out of the 3 are proportional. Let's check the bottoms. So that's UT over U prime T prime. Or in other words, 9 over 6. That's also going to be 1.5. So the good news is that these are proportional triangles. They will produce the same scale factor. Now we should, again, check the other version of it, right? And so we have like, 12 over 8, which is 1.5. But we also have 8 over 12. And 8 divided by 12, according to my calculator machine, is 0.6 repeating. Okay, 0.6 repeating. So looking at the triangles, we're going from SUT to S prime, U prime, T prime. I'm actually reducing. And so I'm actually going to reject 1.5, and 0.6 is going to be my answer. Okay, and so I was checking for some like proportionality because there's no point checking a scale factor unless we know these triangles are similar, right? And so I was checking the same ratio value, the proportionality of these triangles first. But I acknowledge like ratios can be flipped, and so I could write them as like 12 over 8, or I could write it 8 over 12, and those do produce different scale factors. 10 over 15, 15 over 10, 9 over 6, 6 over 9. And so we do want to pay attention to which triangle is larger than the other, because that could tell us which version of the scale factor, because there's always two versions of the scale factor are valid. In this case, the valid one definitely was going to be the smaller, all right? And so in quick review, the stuff you have to know basically about similarity, right, is a definition. All corresponding angles are congruent. All corresponding sides are proportional, which means we're checking same ratios. And so if I just have two triangles, that's what this means. I have to know all three sets of angles are the same and all the sides have the same ratio, which means I can definitely find the scale factor, because if I take the side lengths ratios, the scale factor should be the same, but I know I should get two scale factors, and I have to decide if I'm getting larger or smaller and pick the appropriate one, right? Okay, so that's what I have for this part. Looks like what we have next. Oh, we're filling in angles and sides next. That's fun. Okay, cool. That'll be part, 4, I think.